Hello students, welcome to this session. This is the second session of chapter first of NCERT science book class 10th. In this chapter we are studying regarding chemical reactions and equations. During last session, we have understood what the chemical reactions are and how the chemical equations are formed on the basis of word equations and the literature of chemical reactions, basically. During that session, we have seen that on the basis of the literature of chemical reaction, we can present the chemical equation by two ways. First way is by word, that is called as word chemical equations, and on the basis of word chemical equations we may represent the chemical equations by putting the chemical formula of reactants and products. That type of chemical equations is called as symbol chemical equation. In this session, in context of symbol chemical equation, we will discuss the balanced and unbalanced chemical equation and how do we balance the chemical equation. With certain example, we will understand regarding balanced and unbalanced chemical equation. Thereafter, we will learn how to balance the unbalanced chemical equation. First example, suppose magnesium is burnt in presence of oxygen, and magnesium oxide is formed. Magnesium oxide is formed. Firstly, we write this chemical reaction in word. Suppose here magnesium plus oxygen. Magnesium oxide is formed at the end of chemical reaction. When the magnesium is burned, here burning is the factor, external factors. Now this is the word chemical equation, and it is presented by using the chemical formula of the reactants. These are the reactants, and this is product. And these are the chemical formula of reactants and products respectively. Now you count the atom number of both the sides. This side, LHS side, 1 magnesium, RHS side also having one atom of magnesium. But here, two atoms of oxygen are participating in chemical reaction. But this side, RHS side, only one oxygen atom is there, combined with magnesium, one atom of magnesium. So, the number of, particularly the number of oxygen atom of LHS side is not equal to the number of oxygen of RHS side. In this case, this chemical equations is called as unbalanced. Is called as unbalanced chemical equation. According to law of conservation of mass, the chemical equations pertaining to chemical reactions must be balanced. The number of participating atoms of reactants as well as products must be equal according to law of conservation of mass, because according to this law the total mass of substances participating in chemical reactions, that means the total mass of the reactants must be equal to the mass of the products, because during chemical reactions mass is neither be created or nor be destroyed. So mass of reactants, total mass of reactants, participating reactants in the chemical reactions must be equal to the mass of the products. We know that atom of elements or the compounds which are participating in the chemical reactions accounts for the mass of the substance. The mass of the substance depends upon the atomic mass, because the atoms combines together and form molecules, in a certain pattern to get the stability. We know the molecules may be of element and compounds. The number of atoms found in a molecules is the accounts for the total mass of the particular molecule. Just we have discussed and found that mass of any substance depend upon the number of atoms, participating atoms, which are forming the molecule of the substance, participating substance, participating reactants and products. Show the number according to the law of conservation of law. The number of atoms of a particular element or compounds of participating reactants and products of the chemical reactions of both the sides must be equal to each other. So it is quite essential to balance the chemical equation which is written on the basis of the word chemical equation. Just here we have written the symbol chemical equation by using the chemical formula of participating reactants and the products. But we have not done balancing of the atoms of both the sides. So this presentation of the symbol chemical equations is unbalanced, and in this case this chemical equation is called as skeletal equation. That means the unbalanced chemical equation, which is written just on the basis of the word chemical equations, is called as a skeletal equation. So at the time of final presentation of the chemical equation, the balancing of the chemical equation must be done. After writing the skeletal equation, certain steps we have to follow to balance the chemical equation. We will study here how do we balance the skeletal or unbalanced chemical equation. Just in this case of formation of magnesium oxide, when the magnesium ribbon is burnt in presence of oxygen, we will do the balancing. There is certain steps we have to follow to balance the unbalanced chemical equation or skeletal equation. Firstly, we write the first step is on the basis of literature of chemical equation or on the basis of word chemical equation, we write the skeletal equation by using the chemical formula of reactants and products. Here, this is a example of a skeletal equation. First step is this. We write the skeletal equation of any of the chemical equation. Thereafter, we prepare a table like this. Table. This is the second step. This is the step number second. And we draw 3 columns. In first column, we write element, name of element or symbol of element, atom of elements. And second column is for number of that particular atom of element of LHS side, and this column is for number of atoms or RHS side. Here only 2 elements are participating in chemical reaction. First element is magnesium, second is oxygen. Only we will represent the element, atom of elements, by using the symbol. Only 2 elements are participating here in this chemical reaction. Now we will count. Now we will count the number of atom in reactant side, LHS side. Number of magnesium is 1 at LHS side. RHS side also 1. LHS side number of atom of oxygen is 2. And RHS side 1. The number of atom of both sides for magnesium is okay. Both side numbers are same. But in the case of oxygen, LHS side number of oxygen is 2, but at RHS side number of oxygen atom is 1. So we have to balance the number of oxygen here. 2 by simply जो है कि putting 2 before magnesium oxide molecule, we will balance here. Now number of oxygen atom RHS side is 2 or LHS side is also 2. But by putting 2 before this molecule, the number of magnesium molecule is increased by 1. Now we will जो है कि put 2 here. Here in this case, the 2 is the numerical figure. This numerical value which is put before the chemical formula of reactants or products are called as stoichiometric coefficient. Stoichiometric coefficient. Stoichiometric coefficients is the smallest integers or whole number. Actually, stoichiometric is the set of smallest integers of whole number which is used before the chemical formula of reactants and products to balance the chemical equation. A smallest set of smallest integers, you may tell whole number. The smallest means both sides, the numerical value must not be common factors. Suppose here instead of 2 we are जो है कि putting 4 and 2 here. That means both sides, all the chemical formula consisting of reactants and products are having 2 common factors. So here the coefficients or the numerical value put before the chemical formula of reactants and products are not smallest. 2 is the common in each of the numerical value. So we have to put the only smallest coefficient, smallest numerical value. So this type of the coefficient is called as the stoichiometric coefficient. That is the smallest. So we will cancel the common factors of all the chemical formula of reactants and products by doing cancellation of the common factors. Now by other some example we will study how do we balance the chemical equation. In last session we have studied how do we prepare hydrogen gas in laboratory. When the dilute hydrochloric acid is poured on the granules of the zinc chloride is formed and hydrogen gas is evolved. Hydrogen gas is evolved. We will put arrow here. And this is the formula by which we prepare hydrogen gas in laboratory. And this is the word representation. This is the word chemical equation pertaining to the chemical reactions to prepare the hydrogen gas in laboratory. Now we will present this chemical reaction in symbolic form. The chemical formula of zinc is Zn. And hydrochloric acid's chemical formula is HCl. This is arrow which is put between the reactants and products, zinc chloride, ZnCl2 and hydrogen gas. And this is this presentation of the symbol chemical equation on the basis of word chemical equation or the literatures of the chemical reactions is called as skeletal equation. Just I told you. Now we will test whether the number of atoms of both the sides are equal or not. By same way just we have discussed before. Now here we will prepare a table. This is the second step. First step is to write the skeletal equation. Second step is step number second, to prepare a table having 3 columns. This column is for element. This is LHS, RHS side, and to write the number of atoms of particular atom. Here participating substances are zinc and hydrochloric acid, and here the atoms of the elements 1, 2, 3. 3 types of the atoms of elements are participating here. They are also called as formula unit. In each chemical formula, the atoms or ions or the molecules represents the formula unit. Suppose in the case of, we will understand here formula unit, HCl having 2 types of the atoms. First is atom of hydrogen. This is ionic form of the hydrogen, and Cl chlorine, atom of the chlorine, negatively charged atom, anion, and this is the cation. And by the electrovalency, they combine together to form the HCl. For one formula unit, hydrochloric acid represents the one ion of hydrogen and one ion of chlorine. One formula unit of hydrochloric acid, HCl, consists of one atom of hydrogen and one atom of chlorine. So at the time of the balancing, we will consider the formula unit. How many participating atoms and ions are there? Accordingly, we do the balancing. Here, firstly, we will write the first element Zn, then hydrogen and chlorine. Three atoms of elements are participating in this chemical reaction. Now we will count the number of zinc of LHS side. 1. RHS side also 1. Hydrogen LHS side 1. But at RHS side 2. Chlorine this side LHS side 1. RHS side 2. For our ease, at the time of balancing the chemical formula, firstly we will select the complex or biggest chemical formula of reactants or products of both sides, which is the biggest we will select. So here the zinc chloride is the biggest. We will make it a base to follow the steps of balancing. Here we will apply the heat and trial method. This is called as heat and trial methods. There is no specific methods, only applying our mind. After selecting the biggest chemical formula of the reactants or product, we only apply the mind, our own wisdom. This is called heat and trial methods. Here we will make it base. This is biggest and most complicated chemical formula. Now in zinc chloride, both side 1, no problem. Then chlorine, RHS side 2 and LHS side 1. In order to balance the number of chlorine atom in LHS side, reactant side, we put 2 before the formula unit of hydrochloric acid. We put 2 here before the formula unit of hydrochloric acid. By putting this coefficient 2 before the molecule of hydrochloric acid, we not only balance the number of chlorine atoms, but we also balance the number of hydrogen atom of both sides. RHS sides, the number of hydrogen atom is 2. So by putting these two coefficients before HCl, hydrochloric acid molecule, we also balance the number of hydrogen atom of both sides. Now we will rectify the number in this checklist, in this table. Now the number of chlorine atom is 2 and hydrogen atom is also 2. Now we will finally overview. We check this table, this checklist. The number of zinc atom both sides 1 and 1. It is okay. Similarly, the number of hydrogen atom both sides 2 2. Okay. Number of chlorine atom both sides 2 2. Okay. This is the balanced. Now this is the balanced chemical equation. Finally, we will write the balanced form of the chemical equation at final state. That is the final state. ZnCl2 plus H2. Here one thing you should always keep in the mind, that we only put the coefficients before each formula unit of reactants and products to balance the chemical equation. We never change the ratio of atoms of any of the formula unit of reactants and products. We will not change this ratio. So at first step we put bracket, cover the each formula units by bracket. This bracket indicates that we have not to touch the ratio of atom of formula unit. Now by another example which is given in your book, we will understand the improved way of balancing the chemical equation which we have discussed just before. That is the standard form of the balancing of chemical equation which is given in your book. We will discuss now. When the water vapor is supplied on hot iron, iron is ferrous, Fe, and water vapor is supplied. This is the gaseous. Water is in gaseous state, water vapor, and this is solid. In this case, after chemical reaction, Fe3O4, this is the iron oxide, is produced side by side, hydrogen gas is released. This is gas. To make the chemical equation, we will also use certain alphabets to indicate the state of the reactants and products also. This is solid. We have to balance this skeletal equation. At first step, just I told you, we cover each formula units by bracket, just like this. bracket here. Fe3O4 plus H2. These brackets indicate that we have not to touch the atoms ratio of the formula units. Any of the formula units we have not to change the atom proportion. Here in second step we prepare the checklist of the table as we have been doing in this session. This is column for element. In next column, number of atoms of element in LH side. Number of atoms of element in RHS side. Clear? In this chemical reaction or equation, first element is iron, Fe. Second, hydrogen, H. And third one is oxygen. Instead of writing the full name of the elements, we here use the symbol of each elements, participating elements. Clear? Now Fe, LHS side, number 1. And then hydrogen this side 2. Oxygen 1. Now we will write the number of atoms of RHS side or product side. Fe 3, oxygen 4, oxygen row is this, and hydrogen 2. Conventionally, to balance this chemical equation, firstly we select the complex formula unit having more number of atoms, the biggest formula unit. This is the biggest. And on the basis of, we will start balancing by heat and trial methods. By applying our wisdom, we start balancing by making base this Fe3O4. Fe this side, RHS side, number of iron is 3. Number of iron is 3. So in next step, that step is fourth step. Just we use coefficient 3 before this Fe of LHS side. Fe 3 plus H2O Fe3 we also Fe3O plus H2 bracket. Now we have done balancing of atoms of Fe, iron, both sides. Now we will consider the number of atoms of oxygen. This side number of oxygen is 4. This side 1. This side 1. So to make this side 4 number of atoms of oxygen in fourth step. This is the third step. Sorry, this is the third. In fourth step, we will put 4 before H2O of LHS side. By this way, we also balance the number of oxygen of both sides. But after putting 4 coefficients before this formula unit H2O, we are making the number of oxygen balanced, but increasing the number of hydrogen this side. Now the number of hydrogen of LHS side becomes 8. So to balance the number of hydrogen this sides, we have to put 4 coefficients before this formula unit of the hydrogen in fifth step. Now we will write the fifth step here. Fifth step. Step number 5. Fe plus 4 H2O and Fe3O4, and we will put 4 coefficients before H2 formula unit. By this way, we balance the chemical equation. Now we will check with this checklist. The number of Fe, this side we made 3, and the number of hydrogen this side after balancing becomes 8, and this side also 8, and number of oxygen LHS side became 4, and this side 4. By this way, both sides the number of atoms of respective formula units are same, and thus we have balanced this skeletal chemical equation. This is the final step. But finally we will represent the balanced equation after removing the bracket in sixth step. That is the final step after removing the brackets of each formula units of reactants and products respectively. For H2O. This is the final balanced equation of this chemical reaction of this skeletal equation. By this way, we studied how to balance the chemical equation. In next session, we will discuss regarding classification of chemical reactions, types of chemical reactions in next session. Now I am concluding this session. You students continue with us, watch the videos which are available on Institute's YouTube channel. You subscribe the channel, get benefited, as well as help the Institute in promotion of YouTube channel. Thank you very much.